All right, we're going to look at the derivative of exponential functions and log functions. So we had talked before about the e function in terms of like compound interest and compounding continuously kind of thing. And now let's do like the derivatives. So the derivative of e to the x is actually just e to the x, okay? So if I have 3e to the x, if I'm finding the derivative, that's just 3 times the derivative of e to the x, which is just going to be 3e to the x. Okay? So similarly, if this 2/3 e to the x, that's just going to be 2/3 times the derivative of e to the x, which is e to the x. All right? Now what if we have the natural log? So natural log of x, the derivative of that is going to be 1 over x. So we can use these log rules here and pull out the exponent out front, right? So this is really 3 times natural log of x. So when I do the derivative, that's 3 times the derivative of natural log of x, which is 1 over x. So that's just 3 over x. You can do the same thing here. That's really 5 times natural log of x. So when I do a derivative, that's 5 times natural log of x derivative, which is 1 over x, to leave me with 5 over x. ln of z, just because it's a different variable, doesn't mean anything different. So that's just 1 over z. And 4 natural log of x, that derivative is just going to be 4 times 1 over x to give me 4 over x. Right? Now the reason that e to the x, the derivative, is itself is because of this next rule here. So if we want the derivative of any base, so a to the x, that derivative is natural log of a times a to the x. So if I think about doing e to the x, that derivative is natural log of e times e to the x. Well, natural log of e is just 1, so that is why it's itself. But let's do some of these. So I have 2 times 3 to the x. So that derivative is going to be 2 times the derivative of 3 to the x, which is going to be natural log of 3 times 3 to the x. I forgot my equal sign here. So 2 natural log of 3 and then times 3 to the x. Okay. 5 to the x, that derivative is going to be ln of 5 times 5 to the x. We could rearrange it and say 5 to the x, natural log of 5. Either way, it's the same thing. And then let's try this one here. So 6 to the x is going to be natural log of 6 times 6 to the x. And then we have 7 times natural log of 9 times 9 to the x. Not too much I would really clean up there, to be honest. So we got 12 to the x minus 2 to the x. So natural log of 12 times 12 to the x minus natural log of 2 times 2 to the x. All right, what if we have other log functions? So natural log has a base of e, right? So that's why we get 1 over x. Because of this rule here, we have 1 over x natural log of a. Well, for natural log of x, we get 1 over x, and then natural log of a is the base, which is e, and ln of e is just 1. So that's why we get 1 over x. Okay? So let's try this. We got log base 2 of x. So 1 over x, natural log of 2. Log 4 of x. So the derivative is 1 over x, natural log of 4. Log of x. 1 over x, natural log of the base. When there's no base here, it's understood to be 10. And I have 5 times 1 over x natural log of 23. I can rewrite that as 5 over x natural log of 23. all right? Now let's do just a whole bunch of mixed ones, all right? So we're just finding the derivative with respect to the variable given. So that's 2e to the x minus natural log of 8 times 8 to the x. So we have 4 over x natural log of 3. And I said x, and that really should be a t because that's the variable I'm in. T natural log 3. And then minus 1 over t. Now we got w. So natural log of 3 times 3 to the w plus 1 over w natural log of 10. Y to the 5th, that's a normal power rule, 5y to the 4th, and then e to the y, the derivative is just e to the y. Ooh, let's throw some tangent lines in here. So find the tangent line to f of x is natural log to x at x equals 2. So I'm going to find the y value just because I know I need a point and my slope. So my point, if it's 2, then f of 2 is log base 2. And remember, evaluating a log is asking what exponent is the base raised to get that value. So 2 to what power is 2? And that's going to be 1. And now I can find the slope, because the slope is the derivative at a point. So the derivative is 1 over 2, I meant x, a natural log of 2. Get ahead of myself there. And then I can plug in 2. So 1 over 2 natural log of 2 is that slope. So y equals that slope times x minus the x value plus the y value. Right, find the tangent line to this one. So I'm going to do the point again. So I've got to find g is 0. So 7 to the 0 plus 4 times e to the 0. Anything to the 0 power is 1. So 1 plus 4 times 1, which is 4, to give me 5. Now something interesting about this point here, 0, 5, is the y-intercept. So I can put it in that point slope form, or I can put it straight into y equals mx plus b form. So let's find the derivative, because that's my slope, remember? So natural log of 7 times 7 to the x plus 4 e to the x. And then I can substitute in 0. So that's just natural log of 7 plus 4 as my slope. So I can say y is natural log of 7 plus 4. And I might want to change that around and say 4 plus natural log of 7 so that, you know, I know if I ever go to use this, that it's not natural log of 7 plus 4. I guess I could throw a parenthesis around it instead, but sometimes easier just to change it around. And then plus the y value. So it's in that y equals mx plus b form. All right. And that is all for this section. So if you have any questions, let me know.